Been there before. We're going again. This time to stay. Visionaries and dreamers imagine the future. Engineers and scientists build it, using math and science as forms of art, creating technologies, transforming societies. Now, we take civilization to the stars on a journey to explore and build. A gateway, an outpost, the future.
Good afternoon and welcome to our show, STEM Forward to the Moon. We're live from the Apollo Saturn V Center at NASA's Kennedy Space Center in Florida, where we just wrapped up a 2-hour celebration commemorating the 50th anniversary of the first ever walk on the surface of the moon. We turn now to the future of space exploration, to you, the students and educators. Thanks for joining us and welcome to our show. I'm Stephanie Martin from NASA's Office of Communications, and I'm here with my co-host and friend Nilofer Ramji from NASA's Office of STEM Engagement. We are part of the Artemis generation of explorers. We're going back to the moon, and this time to stay.
We just saw the new Artemis branding, which is truly a nod to the Apollo missions. What many people don't know is Apollo had a twin. She was a woman named Artemis, goddess of the moon. As the Artemis generation, we need to develop the skills to get us to the moon and beyond. NASA's Office of STEM Engagement works with educators, schools, and other organizations like museums to immerse students in NASA's work and enhance literacy in science, technology, engineering, and math. Generally, we're here to inspire the next generation to explore.
Coming up, we'll see an Artemis mission through the eyes of middle school students from museums across the country. We'll also see those same students perform experiments that show how you can recreate them from your home using things that you can find around the house. Later in the show, we'll also have a message from a special celebrity guest.
We want everyone to join the Forward to the Moon conversation using the hashtag NASASTEM on Twitter. My team is standing by to answer your questions on social media. I hope you join our conversation online. Let's get started. As Stephanie mentioned, I caught up with middle school students across the country this summer who used their imagination to see what it would be like if they took over an Artemis moon mission. They simulated a launch, arrived at the lunar gateway, took their first steps on the moon, and even collected samples on the lunar surface. First up, we'll take you inside mission control from the Cosmosphere in Kansas.
Welcome to the space launch, Artemis 3 crew. You have been training for many months for the greatest adventure of your whole life. I know you're a little bit nervous, but that is normal. You will be exploring our solar system, beginning with the moon, and eventually onto Mars. When you hear the words, go for launch, all systems will be a go.
T-minus 3 minutes and counting.
I think it's important for NASA to send people to the moon and to Mars because they can do experiments to help people back on Earth.
What excites me about Artemis is that it's going to have the first woman on the moon, and there hasn't been one before, and that's really cool.
Artemis 3, you are go for launch.
Main engine start. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Solid rocket booster ignition and lift off. Artemis is clear the tower.
Welcome to the solar system, Artemis 3. You just passed the International Space Station and should see the lunar gateway and moon in the distance soon. Navigator, fire rockets on lunar orbit insertion now.
Thank you, Capcom. We will check in as we near Gateway and are getting ready to dock at Astra.
This is one step closer to a future where better things can happen.
So here at Kennedy Space Center, we have Launch Complex 39. That is where pad 39A and 39B were used for the Apollo missions and are key to the future exploration of human spaceflight. Pad 39A is where SpaceX will launch our astronauts in the future to the International Space Station, and you can see that on the left-hand side of your screen. Pad 39B is on the right, and that is where our heavy lift rocket, known as the Space Launch System, will carry the Orion spacecraft for Artemis missions to the moon and on to Mars.
We've been hearing a lot about Artemis today. Stephanie, can you tell us a little more?
To really simplify it, our Apollo missions were focused on getting astronauts safely to and from the moon. For Artemis, we're going to send our astronauts back to the moon, and there they will explore. And they will utilize that experience to prepare us to take the next giant leap to send our astronauts to Mars.
And Artemis will require a heavy lift vehicle, the Space Launch System. The students we met at the Cosmosphere also conducted an experiment using balloons as air-powered rockets to launch the largest payload possible.
This science activity teaches students what it takes to launch a payload into orbit and even how slight variations in weight can affect performance. Let's take a look.
Here with me we have Melissa from the Cosmosphere in Hutchinson, Kansas, and she's going to talk to us about an activity these guys are doing.
Yes, they're doing the NASA activity, heavy lifting. It is a payload activity to test the amount of payload they can evenly distribute and how to distribute it onto their rocket ship. Each paper clip is equal to 2 grams of weight, and their challenge is to get as many paper clips onto the rocket as possible and be able to reach the ceiling. You just need an elongated balloon, some paper clips, and a clothespin to stop the airflow, and some masking tape.
All right, so why don't we check out what we have going on this side? It looks like Drew and Emma over here have some of their activity started.
Yes, Drew has a strategy where he's going to condense up his payload into a baggie and distribute it onto the rocket and experiment with the best location to put his payload for the maximum height. And Emma has a different strategy where she is chaining the paper clips and will evenly distribute them onto and tape them onto her rocket to maximize her payload and the height of her rocket.
Right, and then the idea is to test the different payloads to see what happens or which one launches?
Exactly, so they're going to start with a very light payload and they'll increase their tests each time by a few grams until they maximize their payload.
Excellent. So why don't we see what it looks like to launch this thing? So it looks like Madeline and David have finished their products.
Yes, we have a couple different design ideas. One is to keep the payload together and at the bottom. And then the other design is to chain the payload and distribute the weight all the way down the length of the rocket.
Oh, great. Very nice. So are we able to watch one of these get launched?
Sure, let's try it.
Okay, let's try it out. Okay, so we're going to launch. Ready? Is everyone counting? 3, 2, 1. Whoa! That's amazing! So why don't we try this with another payload?
All right, so Madeline and her partner have put an additional paper clip onto this balloon.
I'm really excited to see what happens with this one. Are you guys excited?
You ready?
Okay, let's count down. Ready? 3, 2, 1. Whoa! So for those of you who would like to try this activity at home, please feel free to visit the website at the bottom of the screen, and you're more than welcome to partake in this really awesome exercise.
The heavy lift experiment and many others are in our STEM Forward to the Moon activity guide. Parents, educators, and students can go to the website and download the book. There is a ton of really fun kitchen science in there.
I had a lot of fun with them myself. In fact, the water filtration activity you will see coming up was my favorite. And Stephanie, all of these activities can be done at home using the activity guide. From launching to living on the moon, there's a lot to learn.
Museums across the country are hosting watch parties just like the one that is in the National Mall in Washington, D.C. It was coordinated by NASA and the Smithsonian's Air and Space Museum. Here you can see the monument in the background with all of the exhibits along both sides. Many of them have big events that are being hosted even tomorrow to commemorate the big Apollo 11 mission.
And each night this week, an image of a Saturn V rocket was being projected onto the side of the Washington Monument. And starting tonight and tomorrow, a 17-minute animated show will tell the story of the launch and landing of Apollo 11. That's happening at the National Mall in Washington, D.C. If you're in the nation's capital this week, it sounds like something really worth seeing.
It really does. As you can see with that That rocket on the pad as it's displayed on the monument, it's just amazing. I wish I was in DC if I wasn't actually able to be here with all of you today.
Exactly, and despite the heat index, it would have been a great adventure.
It sure would have. So a few moments ago, we saw a mission simulation at the Cosmosphere where we had students actually in a mission simulator. I'm amazed how interactive these museums are.
Right, and it's so great to have these experiences available to the students. NASA partnerships are crucial in engaging students in NASA's mission. Not only do they provide learning opportunities for students, they also enhance the capabilities of educational institutions and support educators to better engage the students.
At the Columbia Memorial Space Center in California, for example, students can return to the moon or voyage to Mars in their interactive space mission simulator. They're a Challenger Learning Center where students can experience the journey of exploration and teamwork.
Exactly, and students there took their imagination to new heights as they thought through what it might be like to be aboard the Lunar Gateway, the station that will orbit the moon and become a rest stop as we travel further to Mars someday. I was there with our camera crew as these middle schoolers prepared to land on the moon. They had a lot of fun. Let's watch.
Gateway, tracking your orbit. How do you read for landing?
Mission control. Orbit established for landing on the moon's south pole.
I think it's important to send people to the moon and onto Mars because discovery is a big thing, and the more you explore, the more you know.
Initiating system checks on lunar lander. Power systems.
Power systems, go.
Communications.
Comms, go.
I've always wanted to go to the moon. I wanted to be one of the first women on the moon. I wanted to be the first. So that kind of be like big dream come true that we're going back during my time.
Environmental controls.
Environment controls, go.
I think the most important experiment to do on the moon would most likely be seeing if we could find some way to make people able to live on there. It's going to be the first woman to go on, and it's showing just how much things have changed since the first landing on the moon.
Flight systems.
Flight systems, go.
Lander systems responding with green across the board. Confirm, Houston.
Confirmed Gateway. Lander systems green. Proceed with descent operations.
Roger, mission control. Proceeding with descent operations. What excites me the most about going forward to the moon is like creating a whole new life and being able to discover more than we thought.
Lunar expedition suits are secured.
Expedition team moving to lander.
What excites me the most about going forward to the moon is the learning opportunity. I think it's amazing that during my lifetime and during, like, especially me at this age, I'll be able to experience something like this.
Expedition team has entered the lander.
Hatch is secure.
Pressure check on lander.
Pressure good, holding nominal.
Initiating release.
Seals released.
Lander backing away.
2 meters, 4 meters, 6 meters.
You are clear, Expedition Lander. Godspeed, Chloe and Lenora. Safe travels, Expedition. And don't forget our souvenirs.
The Lunar Gateway that these young women just shared with us, it is such a different approach from what we had during Apollo.
That's right, Stephanie. It's a huge innovation. Gateway gives us the opportunity to land anywhere on the surface of the moon. It will also be a rest stop and staging area as we continue to go on to Mars.
Now, a journey to the moon takes about 3 days each way, and a great way to pass the time is with music.
Stephanie, music has actually been part of space travel from the beginning, right?
It really has. There were pre-launch songs, shuttle crew wake-up songs, and some astronauts even played instruments on the International Space Station to bring a part of home to the space station with them.
With NASA returning to the moon by 2024, we asked people what they thought should be on the playlist for the journey and created Moon Tunes. You can listen on Third Rock Radio or use the hashtag NASA Moon Tunes to learn more.
One of the tunes that made the playlist is the song Moon in the Water by Dawes. But for our astronauts, when they travel to the moon, one important aspect is going to be making sure they have clean water on the moon. Nilifer, you recently worked with students on a water filtration experiment.
That's right, I did. This activity gets students thinking about some of the necessities of survival when it comes to living and working in space. In this case, we looked at some of the science behind cleaning water and creating a water filtration system. Let's go back to the Columbia Memorial Space Center and see how it went.
We're with Brianna at the Columbia Memorial Space Center, and today we're going to be doing a cleaning water activity.
Yeah, so cleaning water is so important.
Right.
So I thought, we can make a water filter activity and just really get the importance of water and why we need clean water.
Exactly, and as the astronauts say on the International Space Station, tomorrow's coffee was yesterday's coffee.
Got to recycle everything we can.
Exactly.
So right here, I have some necessary materials that we do for the filter.
Great.
I have some beans, different kind of beans, some aquarium gravel, because it's very colorful. I have some peas and also rice and our favorite, cotton balls.
Excellent.
Also, just to organize some things, I have, a filter to filter it through, some goggles, safety first.
Exactly.
And also, I got some pH papers, so we can actually see if our water is filtered.
Awesome, so we have Jackie and Neve continuing the activity?
Yeah, so it looks like they've already started their filter. They have
colorful.
Yeah, they have beans, green peas, some rice, aquarium gravel, and it looks like they're gonna add their final step, which is cotton balls, it looks like.
Oh, excellent.
Yeah, it's really easy, and for our dirty water that we made, we actually used Italian dressing, which I think is really fun.
That's really awesome. So what you did was you mixed water with the Italian dressing?
It's that easy.
Wow, okay.
Other times, I like to just go outside and grab some dirt.
That's even more fun.
I love it. I love playing with dirt. And it kind of gives a real feel. It's real dirty water. And they get to test it out and see if it's going to be clean.
And when astronauts are on the Lunar Gateway, they're going to need systems like this to be even more efficient.
Heavy-duty systems.
It looks like we have a completed activity here.
Yeah, so it looks like everything is ready to go.
Great, and the goggles are on.
So safety first. I'm glad that they're ready for that. So now all they need to do is just add the dirty water.
Excellent, and that water doesn't look too dirty to me. I think we need to give it a stir.
Yeah.
Oh, there we go. Look at that dirty water.
So he's mixing the Italian dressing and the water.
Excellent.
So now I would probably say it's good to try out.
So we're gonna try this out now?
Yeah,
let's
try
do
out.
it.
I'm hoping it works.
I hope so too. Fingers crossed. Oh, wow.
It's starting to go through. It's going through all the layers.
That's faster than I would expect.
Totally. And I'm actually really surprised. It looks very clean.
It looks very clean. For those of you interested in participating in this activity and many others, feel free to visit the website at the bottom of our screen and take part in this important initiative.
Nilofer, the water looks a little cleaner when it comes out of the filtration system on the International Space Station.
That is true, Stephanie. Our system includes a couple of technologies that you don't normally have at home, which is why we suggest students don't drink the water you filter.
Absolutely not. Now, we want STEM discoveries and experiments to be exciting for everyone.
We do, and even celebrities are getting excited about NASA's STEM activities.
Actress and singer Keke Palmer recently had the opportunity to learn more about our initiatives, and she shared this message about STEM and NASA's Artemis missions.
Hey, Keke Palmer here, and when I'm not on set or in the recording studio, one of my favorite things to do is to learn more about organizations like NASA and what they're doing to push the boundaries of how we understand the world around us. In addition, tons of new adventures are on the horizon, including Artemis, NASA's mission to land the first woman and next man on the moon. There's never been a better time to get involved in science, technology, engineering, or math. Visit nasa.gov/STEM to learn more about how to help NASA get to the moon, Mars, and beyond.
The landing of Apollo 11 is what we are commemorating today. And for the first time, when we land when we land the first Artemis mission, everyone around the world is going to be celebrating, and it's really going to be something we can all look forward to. Now, Nilofer, you recently had a trip to the St. Louis Science Center.
I did. We went to the St. Louis Science Center and talked to several students there. We asked them what they thought it would be like to land on the moon and showed us what they imagined the big event would be like. They were really excited. They got really into it. And I could see our future astronaut class in training.
Artemis, this is Houston Mission Control here. You have 30 seconds to fuel remaining.
We are close, drifting forward a little.
Shut down. Okay, engine stop.
We copy you down, Artemis.
Engine is off. South Pole here. Artemis has landed.
Roger, we copy you on the ground. Welcome to the moon, Artemis. You're looking good.
I would get my classmates excited about Artemis by telling them how we're gonna go to the moon, and I just think that's really cool.
It's very important for NASA to send people to the moon and Mars so that we can learn more about our planets in our solar system, and we can have new people go and experience that.
We see you opening up the hatch, getting ready to take your first steps.
The most important experiment to do on the moon, in my opinion, would definitely be look at ice on the moon and see if there are any signs of anything ever living there.
Artemis, welcome to the moon. As we establish a permanent presence, we are closer to sending the next generation of explorers to Mars. This is Houston, out.
The Museum of Flight in Seattle is celebrating the landing of Apollo 11 mission with a lunar block party for all museum guests this weekend.
The Museum of Flight also hosts the Apollo 11 command module, known as Columbia, which is on display for the guests you see gathered.
When living in space, shelter is vital for survival, conducting experiments, and to have a place to rest when surrounded by harsh conditions of space.
And at the St. Louis Science Center, students explored what it would take to build a habitat that could be sustainable for astronauts to stay in, but also practical enough to live in. Let's take a look.
We're here today at the St. Louis Science Center, and I'm here with Erin, who's going to be showing us a little bit about a habitat activity. Erin?
That's right. Our astronauts have just gotten back from the moon, and they are already designing their next lunar habitats. They are busy at work drawing what they think would be helpful in a habitat to live if they were on the moon.
Great. I can't wait to see what a habitat looks like.
So we've got Evan and Nikki here, and they are working on actually building a 3D version of their habitat.
And look at this. It looks like they've scrounged around the house and found everything from the recycling bin.
They have everything here has been recycled or reused. Anybody could do this at home or school, anywhere.
Habitats are so important because we need astronauts to have clean drinking water and clean air to breathe.
Yes, there's all kinds of different issues in space. What you said, gravity is an issue. And Nikki over here did the laboratory. How amazing is this mad scientist space lab? So he came up with a lot of ways to bring those experiments safely back.
All right, I want to see a completed habitat, Erin.
Let's do it.
Hi, Samaya. Can you tell us a little bit about what you built for us today?
Yes, I built the bedroom, and so in the bedrooms, when you come in, there's a button, an on and off button. So if you want the gravity on, you press the green button, and if you want it off, you press the red button. And then there's a bed, like a rollout bed with a dresser.
Wow. So what do we have going on with Dylan?
Well, I built the kitchen of the habitat, and there is a table right here with chairs that you can push under the table so that way it saves more space. And then it's just the basic stuff like the sink, but then there's a hot water tank inside of the refrigerator to keep more water inside the habitat. And there's a pantry on the side over here.
Wow, you thought of everything. Katie, what do you got going on?
I built the living room and the gym. I thought when you come home from outer space, you would want to relax. So we have a TV and couch and a little bookcase with some chairs you can sit in. And you have a treadmill. You also have some oxygen and nitrogen and a computer.
And what's in the middle of your living room? Because I really like this.
It's a gravity button that you can push on and off. If you want gravity, you can push it. And if you don't, you can push it again.
Okay, so I think we've given people at home a really great idea on how to start their own lunar habitat.
Yeah, your imagination and what you find in your own house is the limit.
I can't wait to do this at home myself.
Yeah.
So for those of you interested in participating in this activity and many others, feel free to visit the website at the bottom of the screen.
So we've covered launch, gateway, and landing the next mission on the moon, but there's another important step to what you've asked students to imagine.
That's right. As important as all of those other aspects of the mission are, we are going to explore. So we asked students at the Arizona Science Center to envision a lunar sample mission at the moon's south pole. This is what their imagination delivered.
Houston Mission Control here. You're at the optimal lunar South Pole location to begin drilling for a core sample of water ice. Are you ready to start sample collection and analysis?
Houston, this is Artemis 3. We're a go for water ice sample collection.
The core drill is in position and rover analytic lab is ready.
Proceed with collection and analysis.
Drilling has started and is proceeding smoothly.
I'm really excited for the first woman to be on the moon because it's a really good achievement for America and the whole world.
I like to think of it as basically a gas station on the way to Mars, because from the Earth to Mars, it's pretty far away. So if we're able to go to the moon and split the hydrogen atoms inside the ice that's hopefully there, and create rocket fuel out of that, I feel like that would be pretty cool.
I think it's important to have activities that really help students understand just how important this step is in possible solar system colonization.
Stop drilling. We are at the 20-inch mark. Block drill to begin collecting sample.
Collection complete. Anchor the drill for core extraction.
The drill is anchored. Begin extraction.
Sample ready for analysis. Open rover sample container.
The container is open and ready. Begin analysis.
I think it's important because it really is the first step in understanding space travel in general. And along with that, especially for Mars, just being able to see whether or not there's possible biological life in the ice of Mars is just amazing, and it could really signal that perhaps there is a greater chance of life in our universe.
I feel like there's not any experiment that's more important than any other, because any experiment is any experiment. They're all equally important.
Analysis complete. Houston, great news. We have 72% water ice and 28% regolith.
Artemis 3, that is great news. Those numbers suggest that this is an excellent location for a long-duration lunar habitat. This is an important step in helping to ensure this generation will be taking the first steps on the surface of Mars. Great work. Houston out.
I feel like we can learn a lot about how the moon was formed, and when we learn more about that, we can learn more about how the Earth was formed and learn more on from there.
I think just being able to say you're there first, really making the mark for the 21st century is just absolutely amazing.
Man, I tell you, these kids are great. I love hearing how excited they are for our lunar missions. And to see them as they walk through these simulations and put themselves in the role of flight controller or an astronaut, it's just inspirational. And I can see how interactive these simulations are. It starts really great conversations in the classroom and at home.
That's exactly what we aim to do with the activity guide. Encourage families to do these activities at home and talk about them. That's really what science is all about. Asking the questions, getting an answer, and then asking the next question from what you learned. And it was so much fun working with the kids at the different locations. I want to send a big thank you to the Cosmosphere, the Columbia Memorial Space Center, the St. Louis Science Center, and the Arizona Science Center for all their help in making this show possible.
It's great to work with such great organizations who have the same goals as NASA.
Exactly. There are great museums, schools, and other informal education organizations around the country doing amazing work to teach and encourage kids about STEM. We are going forward to the moon, and to get us there and onto Mars, we need you, the Artemis generation, to be the next scientists, technologists, engineers, and mathematicians to take us further than we have ever gone before.
To learn more, you can go to our website at www.nasa.gov/STEM, and you can join our online conversation using the hashtag NASASTEM on Facebook and Twitter. We will leave you now with a song from NASA's collection of moon tunes. Thanks for watching, and have a great weekend.
You lie